And we'll be covering integration by parts, and it's just another way to evaluate integrals in Calculus 2. So the general formula for integration by parts is the integral of u dv equals uv minus the integral of v du. And the reason why I didn't want to include u in u substitution in my last video is because right now we both have u in integration by parts and u in u sub, and further on in Calculus 2 you would have to use both integration by parts and u substitution, so it would get confusing, and personally I would just use t as the variable for u substitution. Instead of labeling it u, I would label it t. So for this integration by parts, you would want to know which to label for u and which to label dv. So knowing the Liate rule would help you know what to put for u. So the Liate rule is like what to put in, let's just say like it's a way to, or the order of precedence. So that means if the u is a logarithmic function, we would choose that first. But if there's no logarithmic functions, we go down to the next one, to the next one, to the next one, to the next one. So using the first example, the integral of x sine x dx. Well, to figure out what we would label u, we would look at the Liate rule, or the Liate chart. So we can see that x is a algebraic function, and sine x dx is a trig function. So the algebraic functions would take precedence, and therefore x is the u, and the other part, sine x dx, would have to be the dv to satisfy the original formula. So u equals x, and dv equals sine x dx. Simple. But now we have to find, for the other parts of the formula, we have to find du and v. In order to find du, we have to take the integral of x, or not the integral, the derivative. We take derivative of x. So this will just equal dx. And to find v, we have to take the integral of sine x dx. So that will leave us with negative cosine x. So now we just plug it into this formula over here. So we replace it with, so let me just write it down so you guys can see what I mean. u dv, uv minus v du. So u would equal x, dv would equal sine x dx, which equals uv, so it's x and then negative cosine x, minus the integral of v, which is negative cosine x, and then du, which would equal dx. So from this, we can make it a lot more simpler for our minds to see. We can move the negative out, so it would be plus cosine x dx. Well, we know, hopefully, we know what the integral of cosine x is. It would be negative x cosine x plus sine x plus c. Don't forget the plus c. It is crucial because it is an indefinite integral. And this would be your answer. So knowing this, let's move on to our second example. So this example is kind of tricky, but we'll cover why. So I'll give you a minute to work on this by yourself, and then we'll come back later. Okay, so let's get started. We have the Liate rule again, so let's find out what u could be. Let me get rid of this. Okay. So cosine x is a trig function, and e of x is an exponential function. So that means we'd place cosine x as our u, and e of x as our dv. E of x dx, my bad. E of x dx as our dv. So let's write this down. U equals cosine x and dv equals e of x dx. Okay, so we find the derivative as we did before, which would equal negative sine x dx, and then also we would find v, which is just ex, because the integral of ex would still be the same part. And now we plug it into the formula that we did before. I'll just use this over here just to not waste any more time than necessary. So cosine x e of x dx equals I'm sorry, hold on. E of x cosine of x e of x, which equals negative integral e of x to negative sine x dx. Okay. So from here, you can see that we most likely are unable to just integral this at all. So we'd have to do integration by parts again. So we would follow the Liate rule again, and we can see here that sine is a trig function and e of x is an exponential function. So we'd put sine, or actually, let me just quickly simplify this down to make it easier so we don't have to worry about that negative sign in our simplification. So u would equal sine of x, and dv would once again equal e of x dx. So taking the derivative, we get cosine of x dx, and then v, which equals e of x. So we plug this all over again. So cosine of x ex from the original, just brought it down, plus the integral, which would equal, so we're doing integration by parts again, so it would equal sine of x e of x minus the integral of e of x, not e of x, yeah, e of x, sorry, cosine of x dx. So bringing this down, we could see a trend that you might not see before. So if we were to solve this again, we would end up with repeating answers, and we don't want that. But how would you solve this if we can't avoid the repeating integrals? Well, from here, we can see that this integral equals our starting integral. So I could replace this with a new variable. Let's just call this I. I equals cosine of x e of x plus sine of x e of x minus I, since that equals the same thing. So let's move this I to the other side. Plus I is equals 2I equals cosine of x ex plus sine of x ex. And then we can simplify this down by moving 2 to the other side by dividing everything by 2. So I equals 1/2, and we can also move e of x out of the the equation because it's multiplied, so we can simplify that down further as well. So 1/2 e of x cosine of x plus sine of x. And that, also plus c, don't forget the plus c. And that will be your answer. So your integral equals 1/2 e of x times cosine of x plus sine of x plus c. And that is what you mostly need to know for integration by parts. Just try to remember the Lyautey rule to know what to put for you and the general formula. Thank you for watching. I'll see you in the next video.